Hello and welcome to my presentation entitled From Crisp Packets to Cars. There'll be more on crisp packets later. I hope you're all staying safe and sane in these unprecedented times. It feels somewhat odd not being able to see the audience, but I hope I can keep you interested and engaged for the next half hour. So my name is Dr Buckingham and I'm Managing Director at Xi Engineering Consultants. I'll be taking questions at the end of the presentation. If you don't get a chance to ask a question, there'll be contact details, so feel free to get in touch. So this is one of my favorite quotes. The team at Xi truly work on cutting edge technology before it reaches market. So I get to see literally what's coming every day. But due to client confidentiality, I can't tell you all about it. But needless to say, we live in a time of huge technical change as we exploit the trillions of transistors we produce globally every second. So what is Xi? As a bunch of technical geeks, we decided to rebrand as Xi back in 2011. For us, it represents the damping ratio, which we commonly use in our structural dynamic analysis. For other scientists, it can mean a lot of other different things, such as a killing vector in general relativity. At Xi, we specialize in effectively combining the real and virtual worlds. So we enjoy solving complex science and driving technology forward. We produce cutting-edge simulation, which we validate through real-world measured data. I think Rich just made the quote, all models are wrong, some are useful. Our technical director is very much of that opinion too. We're one of 60 certified COMSOL consultants globally. So as you hear on COMSOL Day, I'm sure I don't need to tell you all about virtual prototypes. Most of you must know a thing or two about these. But I firmly believe that technical innovation, you should utilize all the tools available to you. And in the current times, if you're not using simulation, you're going to be left behind by the competition. As I said earlier, I get to see the future at Xi. We work across many industries. The thing that underlies all of this is a knowledge of physics and how the real world works. This slide is designed to show you about a few of the different things we accelerate, dealing with robotics, monitoring devices, turbines, tidal turbines, the world's largest onshore turbines, and obviously pandas. Who wouldn't deal with pandas? We recently worked with Edinburgh Zoo to rehouse the pandas, because it appears pandas have a much greater hearing range than humans and are very sensitive to both low frequency and high frequency noise. So there's your learning for today. So we work with our clients in a number of ways. There are so many benefits to simulation. I'm sure you're aware of this, but on the right of this slide, I've highlighted a study by the Aberdeen group, which summarizes some of the benefits of simulation for products. Who wouldn't want to get to market quicker with a more robust product at a reduced cost? So that's why we're all here on COMSOL Day. I'm going to describe one of our development journeys with one of our clients called Warwick Acoustics. COMSOL played an integral role in taking this product to market. So let me introduce you to the Sonoma Model 1, which was launched back in 2017. The Model 1 was Warwick's first product they actually brought to market. It's collected 15 global awards now since its launch. And I hope you're all sitting down. The target market they were aiming for is for headphone systems which cost between £10,000 and £30,000. These are aimed predominantly at the professional audio market. If you were trying to take your work home and you ran a recording studio, you'd be looking at spending £100,000 to maybe £200,000 to produce a room which would give you very, very high-end sound reproduction. So the Model 1 actually came in at a snip at £5,000, and its level of sound production well, I was going to say second to none, but it is absolutely amazing. We've got a pair in the office, and if any of you get the chance to pop by, I would recommend giving them a go. The sound reproduction, the way I can describe it is effectively, it's like listening to it firsthand. So following the success of their first product, the M1, we went back to the drawing board with Warwick Acoustics and Xi to try and improve on that, which was no easy task. So the Aperio, which is their flagship headphones, were released last year in 2019. And these retail at £25,000. Since its launch, it has already captured 5 global awards, and according to Oracle Time, as you can probably read, it is possibly the finest headphone system on the market today. So what? So crisp packets, back to crisp packets. There we go, I was losing my track. Effectively, Warwick Acoustics were working in a standard sort of trial and error process when we first met them. They use the predominant material used in the construction of their electrostatic speaker is a foil that is very similar to that you would find in crisp packets. If I was stood in front of you presenting, I would now be eating a packet of crisps and then ripping it apart to show you what a crisp packet looks like. But I'm sure you can all imagine, or you may even have some next to you currently. So the market they were aiming this at is very demanding. Audiophiles do require a highly accurate and precise reproduction of sound. What they focus on is trying to have a system that produces effectively what's described as a flat response, which means over the frequency range, it doesn't distort. So it, as I said, it feels like it's like you're there firsthand. Warwick were busy doing the standard old tried and tested test, trial and error approach when they found us, and they engaged Xi to try and accelerate their development and bring in simulation. So the speaker, if we break it apart, again, I would be waving one of these things or throwing them at the audience. But effectively, you've got a crisp packet foil with a spacer and a wire mesh, and it's all sandwiched together to produce this. This is their initial one, which was a one-sided, single-sided electrostatic, high-precision electrostatic speaker. There's a lot of non-linear behavior in this, and there's a huge number of factors to optimize. So their trial and error, obviously changing one variable at a time, was taking roughly a couple of weeks to do each variable, whereas obviously building a model, we can accelerate that significantly. So the team at Xi produced a couple of MEMS structural acoustic model. We were looking at this in the frequency domain, included the viscothermal acoustics, obviously dealing with boundary conditions, and looking at the nonlinear behavior. We then validate this against the real world data that Warwick had already been collecting. So there's quite a lot. As we build models, generally, we want to understand the principal physics of a product or a system, and then we build them complexity into models, understanding the sensitivities to various factors, and then what we believe to be the real genius of creating models is then actually trying to distill them down into a model which is, you know, fit for purpose and capable of high-speed iterations in order to drive the development. So what we needed to include in here was obviously the different thicknesses, the tension in the foil itself, all the material properties, the wire mesh, the actual weave with it, and align that to the electrostatic capabilities. In order to get the most value from this model, what we did was using the COMSOL app. We produced an app for our clients. so they could themselves get closer to the model and understand what variables and changing different components would do. This is very helpful during the manufacturing process when they're looking at supply of different materials with very slightly different material properties, so they're able to check whether or not they would be able to get the high-end precision that they wanted from certain materials. Following, so it was the first speaker that went into the M1. Following that, we've continued the journey with Warwick, improving on the electrostatic initial speaker, so moving it to the double-sided high precision electrostatic speaker. And obviously within this, again, we're looking at geometry, the thickness, again, different material properties, the foil tension, and as you can see from there, on the right-hand side, this is the second iteration, and this is the speaker that went into the Aperio £25,000 headphone. So having optimized these electrostatic speakers for two of the best headphone systems available in the world, the true market that Warwick Acoustics were aiming at is actually that of the automotive sector. There are substantial benefits from having electrostatic speakers within the automotive sector rather than the traditional copper loudspeaker systems that I'm sure we all have in our houses. So there is, as you can see from this slide, the different applications we're driving this into the automotive sector. So in terms of speakers in seat backs, headrests, the door panels, and the instrument panels. I'll describe a few of these in detail. So the acoustic panels, we live in a world where efficiency and certainly environmental impacts of systems has, well, we're in a climate crisis, so we have to do change our ways and behavior. So these systems, when put into a car, a normal car would have about 8 to 10 speakers, each one of the drivers usually weighing between 250 to 350 grams. The equivalent speaker in this, we're talking about 20 grams, but we obviously have the a fairly heavy amplifier. So there's an immediate weight saving over current systems of about 50%. The power saving as we move to electric vehicles is up to 70%, and there is also a cost saving to be had when using these systems. So new electric vehicles, which are obviously generally quieter than classic combustion engines, we are now actually installing and optimizing these flat panel speakers to produce this extremely high resolution quality within the automotive sector. So we had to look at each of these in turn. So again, falling back on COMSOL and using the data that Warwick Acoustics were producing in the lab. So there is a size saving as well with these systems. A traditional speaker would be sort of 70 to 80 millimeters deep, which restricts where you can actually place them within a vehicle. These systems themselves are sort of roughly 12 millimeters thick, so we can literally put them anywhere. But then we have to look at the material properties, both in front and behind these, to ensure that we can produce very, very high-end audio. So as you can see there, some of the parameterization we set up in these models, obviously material properties, foil tensions, and then looking into the cavity and what materials behind, so that we could ensure that the user got the best audio output. Then we're looking at the panels, actually increasing the size of these systems from what was a relatively small headphone setup. So reconfiguring them from the headphone into a rectangular design so we can produce bigger panels, increasing this. Some of the mesh sizing and the foil that I discussed earlier is quite difficult. As we did this, COMSOL had recently launched their the BEM approach, so we were able to incorporate these into the model and looking at distortion, again trying to create a flat response to frequency. So bringing this to a close, I'm running slightly ahead of schedule, so I may have time for a few more questions. But what did we achieve with this? So we've taken Warwick from effectively the laboratory to the marketplace with 2 products that have won 20 awards between them, as you can see there on the screen. We were able to reduce this sort of 2-week cycle of trial and error to roughly an hour with our models, which we ran both in parallel. So when their first product hit the market, they destroyed the competition and picked up all of these awards. So for a first product, they were extremely pleased. It allowed them to get to the market faster. We obviously optimized and improved the product, but both reducing development time and cost. As you can see, a quote from the CEO of Warwick Acoustics, he was extremely pleased in being able to get to market quicker with a better product and cheaper. But we're all here for COMSOL Day, so we all know what that's about. So the Model 1 onto the Aperio and now into the automotive sector. As I said, if any of you are near our office, we're based in Edinburgh, and would like to have a listen to the M1, please feel free to stop by. It is quite amazing. So in conclusion, using COMSOL multiphysics really as a driving tool to produce these amazing products, all the way from a laboratory-based university product and now into the automotive sector, effectively using the materials in this crisp packet here that you see. It was developed both cheaper and faster, and COMSOL played a tremendous role in this product development. So thank you all for listening. I think I'm about on time now. So are there any questions?
Hi, Paul. Thank you so much for such a great presentation. And I'm sure we have a lot of questions already. Rich, any questions from the audience?
Oh, yes, certainly. And I guess, Mark, I didn't realize about pandas hearing all the complexity that goes into, headphones and speakers that I'd be using in my daily life. So what an amazing talk. I guess my first question, you mentioned that the timelines can be shortened by using numerical tools. Could you, talk me through what the timeline was as an example for one of these products when it comes to making and testing, developing your models?
Well, in terms of what Warwick were doing prior to engaging ourselves, as I said, it was taking them roughly sort of 2 weeks to set up a new product, get it tested, get the results, and then go on to the next iteration. I believe we got our models down to a spin in roughly an hour and a half. And we effectively worked with Warwick for about 4 months before their first product got to market. And we were literally running iterations throughout that entire time. So, for me, it was getting them the best product we could effectively in about a 4-month timescale, which, as I've said, it blew the marketplace away. We came in at half the price point. They were trying to hit the £10,000 to £30,000 headphone, and it's a testament to the COMSOL and the model that we built that it won so many awards.
Yeah, so 4 months worth of work and over 20 awards. That's not a bad hit rate on the award front, is it?
15 on the first one, and then then they go through. We quite often work with SMEs where they'll be designing a product, need to bring it to market, de-risk it, get it out there. So we'll do some heavy modeling session, and then after that they go into a sort of a sales mode, and then they'll start looking at the next product, and we'll be brought into that.
So one thing you showed us was the app that you made. I think it was for Warwick in this case. Can you elaborate on some of the feedback and the outputs you've got from that in terms of how the user found it and where it led them to go forward in that model cycle, that life cycle of the product?
Yeah, well, I think I used the quote "chuffed to bits," which was the exact phrase the CEO used about the app. Obviously, trying to understand the model in that, we don't send reports out, with a 2D graphic of what to understand the model, getting in and about it. So what the model can do using the app, our clients are able to have a look at it, do some testing for themselves, because at this stage we'd built a very solid model. We knew all the sensitivities, we'd optimized it so they could spin it. Even their marketing team got involved, so they were saying, oh, what if the headphones were this big, and they'd stick that size in, or what if they were we use gold, how would that affect it? So it really allowed them to understand the sensitivities to various factors, but also a manufacturing stage, as I said, when the manufacturers came back and say, we've got a very fractionally different material property, for the production run, are you happy with it? They could just run it straight through their app. So it's very valuable for a company, that the sort of SMEs where they're not investing in people and software themselves, but they want to be able to access this, and this is where the COMSOL app works so well for so many of our clients.
Well, so I guess, you maybe partly answer the next question, but I guess, why did you choose to do this work within COMSOL rather than any other FEA tool?
Well, we love COMSOL for many reasons, but predominantly because we class it, or our technical director's phrase he uses, you can lift the lid. So it's not so much of a black box. You can literally have a look and see what coding's in there, and also put our own coding in. So people worry about rubbish in, rubbish out from simulations, but knowing what's happening inside the black box, it becomes less black, and that's why we love COMSOL and use COMSOL so heavily in our simulations.
Cool. I guess probably the last question. So you've looked at the design of the speakers and you've explained how complicated they are beyond what I ever realized. And then you showed the speaker being inside a car cabin. Is the next stage look at how that acoustic environment in that car impacts what you hear? Is that sort of the next stages?
Yeah, so we've initially been trying to improve on the transducers, but what we like to do is holistic system modeling. It's only when you get all the component parts together that you know how that in this case cabin is going to work. But it comes at a time when, with this move to electric vehicles, as I'd said, where cars inherently are going to be much quieter, so we can actually start focusing on making when they're driverless, you may well have your own cinema within these vehicles, but prior to driverless vehicles, electric vehicles, it is about creating very, very high quality sound reproduction within that cabin. So yes, there's quite a lot of work to do within the cabin. The actual OEMs or the car manufacturers themselves focus on this heavily already, so we'll be working with those guys as these are brought into the systems.
Excellent. It definitely sounds like this is a very much an expanding and a growing topic for future work for you guys. So that's great. It'll be good to see what happens, I guess, in the next few years. So yes, thank you for that talk, Mark. I'll hand back to Ksenia to kind of start the break before we have our next session.